All right, buckle up, everyone. We are diving deep today into something that, well, many developers are probably still having nightmares about. That GPT-5 launch back in August 2025. And I'm not even talking about the model itself, really. I mean, the fallout,
Yeah.
the API chaos that followed. Our sources, they're calling it the classic broke the AI internet moment.
Oh, absolutely. It was a genuine catastrophe, and I don't use that word lightly. If you know your programming history, think left pad. But like amplified massively. The problem itself was, well, brutally simple when you look back. A major provider, OpenAI in this case, basically pulled the plug on a whole bunch of older APIs. Minimal warning. And any app hard-coded to those specific APIs, those model shapes, poof, they just face-planted overnight.
Yeah, the collective scream from developers was audible. You could almost hear it. And what's really crucial for you listening right now to grasp is why this wasn't just, a typical server outage. It was much worse. An AI app isn't just one API call, right? As the source material points out, it's like a whole Jenga tower.
Yeah.
You've got custom logic, specialized prompts, deep customizations, all balanced on that one specific foundation.
Exactly. If your entire application hinges on just one provider, one API structure, one model flavor, well, that's the nightmare scenario. When that primary AI service gets pulled, it's not like losing a small piece. You're yanking out that critical block right at the bottom of the Jenga tower. The whole thing, all that carefully tuned logic, those specific prompt libraries, it just collapses instantly.
Okay, so our mission today feels pretty vital for anyone building anything in this space. We need to pull out the key lessons, the mandatory takeaways from that huge failure, and really detail this structural shift towards what people are now calling AI high availability, AIA systems. We need code that can actually weather these storms, this constantly shifting AI landscape.
Precisely. If you're building AI applications, you first have to understand why these systems are, well, inherently so brittle, fragile. And then you need to adopt the structural fixes, the remedies that ensure your uptime isn't just betting on someone else's roadmap, especially when that roadmap moves fast, maybe even a bit recklessly sometimes.
Right. Let's dig into that fragility first, the complexity piece. When we talk about a modern AI application, it's not just like a single function call anymore. These things are complex orchestrations, aren't they?
They absolutely are.
Yeah.
Just think about all the moving parts, all the layers involved. You've got data coming in, so document ingestion, then creating vector embeddings, then the retrieval logic, your RAG pipelines, the prompt templates themselves, which are often super customized, then the actual model doing the thinking, the inference. And then you have to parse the response, make sure it's usable, structured maybe, every single one of those layers. It depends on the underlying model behaving consistently.
And with that much dependency stacked up, even tiny changes way down at the model level can just throw the whole thing off balance.
Yeah.
So this brittleness, it seems to come from two big related issues. Let's talk about the first root cause, the vagaries of the models themselves, the weirdness.
Yeah, the first big one is just the nature of these LLMs. They're opaque, they're probabilistic. We kind of treat them like predictable machines, but fundamentally they aren't. They have these, well, unpredictable shifts in behavior. Every developer's seen this, right? You have a prompt that's supposed to give you nice structured JSON. Suddenly, it starts giving you friendly chat instead. Or your RE system, which was perfectly citing sources yesterday, starts, well, hallucinating references today.
That's a massive mental shift, isn't it? Thinking of these glitches not as traditional bugs you can just squash, but as inherent features of a system that operates on probability.
It really is. And our traditional software development practices, they just weren't built for writing code against a moving target like that, a target that might change its mind. And then you add the second factor, which makes it worse. The sheer speed, the pell-mell development cycle. AI companies are racing, sprinting to push out newer, better models. So those nice, predictable, stately API update schedules we used to have, they've kind of tossed those out the window. Instead, you get continuous, rapid iteration, constant small tweaks, and the result. Those tiny changes can fatally break your carefully tuned, highly tested prompt logic without any clear warning signs.
Okay, so the bottom line for everyone listening is pretty stark then. Stop betting your whole application's uptime, maybe even your business, on a roadmap you fundamentally do not control. If the ground is shaky, the building needs some serious reinforcement, redundancy.
It absolutely does. And that brings us directly to the solution, adopting this defensive and redundant posture. That's what these AIHA architectures are all about. It's moving beyond just backing up your data. We need to back up the reasoning process itself.
That sounds like a pretty fundamental change in how we build things.
Yeah.
So before we get into the tactical checklist, what are the main pillars, the sort of core architectural pieces of AIHA that developers need to be putting in place, like right now?
Okay, there are four essential components. The first one is AIHA proper, real AI high availability. And honestly, this is the hardest part because it means building parallel reasoning stacks. You can't just take a prompt that works great for GPT-4 and expect it to work the same way with Claude 3 or, Llama 3. You have to maintain totally separate RAG pipelines, distinct prompt libraries, each optimized for a specific engine. Their context windows are different, how they follow instructions is different. It all requires customization.
Hold on. If I'm building parallel, completely distinct logic text for each model,
Yeah.
isn't that basically doubling or tripling my development and testing workloads straight away?
Yeah.
That sounds like a massive cost, a huge burden for teams.
It is. There's no denying it's a significant upfront investment, a cost. But you have to frame it as the non-negotiable insurance policy against another GPT-5 style failure. The potential cost of having zero uptime, of your application just dying, that far outweighs the cost of parallel development and maintenance. It just has to be factored in now. Okay, the second pillar is hybrid architecture. This is about mixing and matching, balancing performance, cost, and reliability. Use those powerful, maybe expensive cloud APIs for your main complex tasks, but crucially, combine them with containerized local models you run yourself. Use those for critical fallbacks or for routine predictable queries that don't need the absolute top-tier model.
Okay, so if the big cloud provider has an issue, the application can sort of degrade gracefully, maybe switch to the local model to handle the basics, keep the lights on, essentially. Now, what if the model is still online, but it just starts acting? Weirdly, like you mentioned before, outputting chat instead of JSON. How do we stop that from causing chaos?
Right, that leads directly to the third pillar, smart caching. This is crucial. You need to strategically store intermediate results throughout your AI pipelines. Things like the embeddings you've generated, the processed context you fed the model, maybe even responses you've already validated as good. If the live model starts misbehaving, this caching enables what we call graceful degradation. Maybe the user gets slightly older data or slightly reduced functionality for a bit, but the whole application doesn't just crash and burn.
Resilience by having cushions in place. I like that. Okay, and the fourth component, behavioral monitoring.
This is absolutely vital for catching those subtle, dangerous changes we talked about earlier, the drift. You need systems actively tracking things like response patterns, output formats, even semantic quality metrics over time. You're looking for that behavioral drift before your users start complaining. And a key part of this is implementing automated cross-model equivalence testing. You basically run the same challenging queries across multiple models continuously, just to check they're still producing comparable, high-quality, and correct results.
Okay, that really sets the stage, moving from the high-level architecture into the practical steps. It sounds like putting these four pillars into practice requires some pretty rigorous testing and specific actions from development teams. Let's run through that tactical checklist. What are the 7 key steps people need to take?
Agreed. Let's get tactical. First step, abstract the API layer. Build your own internal interfaces that expose the common AI capabilities you need, like text generation, embedding, classification across different providers. This layer handles the provider-specific quirks, like different authentication or parameter names. And crucially, behind this abstraction, you maintain those separate, optimized prompt libraries and RAG configurations for each provider you support.
Okay, makes sense. Isolate the differences. Next up, we have to plan for change. Deprecation-aware versioning.
Exactly. Change is constant, especially API deprecation. So you need automated migration pipelines. Let's say model A.1 is your current production model. You should already be running continuous validation tests against A.2, the next version, and also against competitor model B.1. Basically, test the future before it gets forced on you.
That feels like maybe the most proactive piece of advice here.
Yeah.
Don't wait to be surprised.
Oh, yeah.
What about making switches quickly when needed?
That's step 3. Model registry and config-driven swaps. All your model IDs, API endpoints, credentials, they absolutely must live in configuration files, not hard-coded, ideally managed by feature flags. You need the infrastructure ready to switch providers almost instantly, and just as important, have automated rollback capabilities if a switch causes unexpected problems.
Right. Fast switching, fast rollback. And if a service just drops off the map entirely, we need fail-soft strategies.
Yeah.
Step 4.
Yeah, design your applications from the ground up to handle reduced capabilities gracefully. Don't just crash. Implement automatic fallback chains. If your primary, maybe complex and expensive GPT-4 prompt fails, the system should automatically try routing that request to a parallel Claude 3 implementation, or maybe even that local model we talked about. Have a plan B, C, and D.
Step 5 seems to be about making that redundancy real. multi-vendor readiness.
This is where the commitment really shows. You have to actually build and maintain integrations with at least two, preferably more, major providers. Optimize the code for each. And here's the part people often skip. You must regularly test those backup integrations, run realistic traffic through them, and maintain up-to-date migration runbooks, step-by-step guides for emergencies. Because if you haven't tested your backup system recently, you don't actually have a backup system, you just have wishful thinking.
That's a hard truth. Steps 6 and 7 seem focused on awareness and ongoing validation.
They are. Step 6 is change monitoring. Be proactive. Set up early warning systems. Monitor provider blogs, mailing lists, API status pages. Alert your team immediately on any deprecation announcements. And ideally, those alerts should automatically trigger testing workflows using the new or changed versions. React to the announcement, not the eventual breakage.
Get ahead of it. And finally, to make sure things stay consistent even as models evolve, contract tests.
Yep. These are your rigorous, comprehensive test suites. They validate the expected behaviors of the contract across all the different model types and versions you support. This is where you implement that cross-model equivalence testing we mentioned. And automated regression testing is key here. When a provider updates their model, even slightly, your test should automatically run to ensure your core business logic hasn't been subtly broken.
Okay, if we zoom out from the checklist for a second, the whole philosophy here seems to be about reframing model instability. Not treating it like a 5-alarm fire or an emergency, but more like an expected part of the life cycle, something you plan for. And this seems to have really pushed the remocal architecture trend, right?
That's absolutely right. Remocal, that blend of remote cloud APIs and local self-hosted models, it's becoming much more common. Teams are enabling local models, often containerized, running right on their own servers or even on edge devices. You use these remocal setups for maybe less critical tasks, for development and staging, for robust testing, or as that reliable fallback. It dramatically reduces your moment-to-moment dependency on any single distant cloud provider, especially during development.
And it seems the most sophisticated applications were already doing dynamic routing, maybe based on cost or latency. Extending that logic to route based on availability or sudden model changes feels like a natural next step. But it really leans into needing that portfolio of different reasoning strategies ready to go.
Exactly. The future, really the present for leading apps, is dynamic model routing. Your system needs to react instantly if a model starts misbehaving or goes offline. If your primary high-performance, maybe high-cost model suddenly breaks or gets deprecated, your router should immediately, seamlessly shift that traffic, maybe to a slightly cheaper, perhaps a bit slower, but still perfectly viable backup model without the user even noticing an interruption.
So the ultimate benefit here, beyond just surviving the next API apocalypse, it's really about competitive advantage, isn't it? Systems built this way, tunable, switchable, flexible, they don't just survive, they thrive. They gain inherent advantages in uptime, reliability, and they naturally become more cloud agnostic, more portable.
Absolutely. Resilience isn't just a feature anymore, it's becoming the defining characteristic of mature professional AI engineering. The applications and platforms that win in the long run will be the ones that master this balance: performance, cost, and rock-solid reliability. And that means mastering building across multiple redundant reasoning implementations. Flexibility, redundancy, they're not nice-to-haves. They are absolutely foundational, non-negotiable requirements in the AI ecosystem we live in now.
Okay, so we've covered the pain of the past, the necessary architecture for the present, and the tactical steps to get there. Let's wrap up with a final thought for you, the listener, to sort of chew on as you think about building your own AI systems. If adopting this AIHA architecture really means maintaining these parallel stacks, separate, optimized prompts and configurations for GPT, for Claude, for Llama, for whatever comes next, are we heading towards a future where being an expert AI developer means you have to deeply master multiple distinct model families simultaneously? Or does expertise shift towards mastering the abstraction layer, becoming brilliant at building the systems that intelligently route and manage the complexity between all these different models? Where does the true skill lie going forward?